In this video, we are going to further our discussion on evaluation metrics. We are going to study about R-squared. Now you would be wondering, what exactly is this R-squared? R-squared is a statistical measure that represents the proportion of variance for a dependent variable that is explained by an independent variable or variables in the regression model. We have all studied linear regression. We know that we have independent variable and dependent variable. The R-squared tells us how much variation in the dependent variable is explained by the independent variable. So it is like a measure of goodness of fit. How much is the independent variable able to explain the variation in dependent variables? R squared explains to what extent the variance of one variable explains the variance of the second variable. The best part about R squared is that its value lies between 0 and 1. And it is independent of the scale of y. Whatever be the scale of measurement of y, the value of R squared will always lie between 0 and 1, and hence it is very easy to interpret. But there are problems associated with R squared. It is very difficult to identify what R squared is appropriate for a model. In some scenarios, a high R squared is always appropriate, while in some scenarios, a low R squared is also acceptable. Now, the formula for R squared goes something like this. It is TSS minus RSS upon TSS, which is nothing but 1 minus RSS upon TSS. Now, you would be wondering what exactly this TSS is. The TSS is nothing but the total sum of square, and RSS is nothing but the residual sum of squares. We have understood the term residual. A residual is nothing but the difference between the actual values and the predicted value. Now let's deep dive into total sum of squares. The total sum of square is a variation of values of a dependent variable from the sample mean of the dependent variable. So total sum of squares is given by the formula summation I is equals to 1 to n yi minus y bar the whole square. So over here we are trying to find the variation between actual y and the mean of y. The total sum of square measures the total variance in response y and can be thought of as an amount of variability inherent in the response before the regression is performed. So the baseline model is nothing but your averaging. So your y bar is your baseline model and you are checking for the variation from this baseline model. That is your total sum of square. Over here, we have not yet applied our regression model. Now, let us understand what is residual sum of squares. Residual sum of squares measures the amount of variability that is left unexplained after performing the regression. RSS is given by summation I is equals to 1 to n yi minus y hat the whole square, where yi is nothing but your actual values and y hat is nothing but your predicted values. Now we have to deal with TSS minus RSS. TSS minus RSS measures the amount of variability in response that is explained by performing the regression. An R-squared statistic that is close to 1 indicates that a large proportion of variability in response has been explained by the regression. And if your R-squared value is close to 0, then it indicates that the linear regression model that we have chosen is not a proper model. I hope the idea of RSS, TSS and R-squared is clear for one and all. Thank you.